Okay, let's consider the following problem. A car banks around a 30-degree turn with a 200-meter radius. If the track is frictionless, what speed should the car approach the turn? Alright, so let's begin by drawing a picture of the situation. Alright, we're assuming the track is frictionless. So let's draw the little curve. That's a curve, that's a bank. And that's 30 degrees. And there's my vehicle. Let's draw a simple box. And this track is frictionless, so basically there's going to be some motion left and right, okay, up and down, and the forces which exert on the body include basically the force of gravity, which is mg, and the normal force, Fn, right? So frictionless, there can no longer be any forces which is parallel to the track. So, if I want this car not to skid, I have to adopt basically that the normal force, okay, we're going to have to draw this in the x and y direction. The y direction has to be equal to mg in the y direction, right? So balances forces in the y direction, okay? And then in addition, okay, I need to make sure that the force in the normal direction, in the x direction, that's going to be equal mac, because remember, there's acceleration in this direction in order to keep this thing in a circular trajectory. Okay, so we're interested in this angle here, all right? And this angle is going to be 30 degrees, right? So this is just going to be simply be equal to, wait, hold on, that's not going to be 30 degrees. This is going to be 60 degrees, all right? So you can figure this out by arguing that this angle is the same, and then this is 90 degrees perpendicular, and so that's 90 minus 30, right? So in other words, this is going to be equal to f of n, the cosine sine, okay, sorry, it's the sine is y direction, of 90 minus theta, or 90 minus 30, which is going to be f of n cosine of 60. Cosine of 30, sorry. All right. Yeah, let me make sure that's right. Okay, so that's perfect. Okay, so this is going to be equal to mg. Now this is in the x direction. This is going to be just going to be f of n. Now here is going to be the cosine of 90 minus theta. That's this angle right there. Okay, which is going to be equal to f of n sine of 30, which is equal to the mass times AC. Okay, so this is 1, this is 2. So 1 implies that f of n is equal to mg over cosine of 30. Okay, so this is very nice because this normal force, the vertical component of it, which would be cosine of 30 of that, exactly balances the force of gravity, which is pulling this object down. Okay, so let's take this, plug into 2. Right? And what we have is basically f of n sine of 30 equal mac. Right? So this is mg sine of 30 over cosine of 30, which is mg tangent 30. This is going to be equal to mac. Okay, so you notice the m's will cancel on both sides. This is the mass of the car. All right, and so we have AC is equal to g tangent of 30. Okay, let's go ahead and compute that number out. Let's bring out my trusty calculator here. Okay, so let's do the tangent of 30, close parentheses, equals, perfect, times 9.8 Okay, and there it is. So that implies this is equal to 5.7 meters per second squared. Okay, now if you recall, this AC is equal to V squared over R, which is V squared over 200, and that's going to be equal to 5.7. Alright, so let's just multiply 5.7 times 200. Okay, so this implies that V squared is equal to 1140. Take the square root of that. Second function is square root of 1140. Close that. And there it is. V is equal to, right down here, 34 meters per second. Alright, and that's our answer. Hope that was helpful.